Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if learning one thing can actually help you get better at something totally different? Think about it, we're always trying to get better at figuring things out, right? But what if training for one type of problem doesn't help with another, even if they look kind of similar? That is the big question a new study is tackling. So the researchers wanted to see if practice with one set of rules for solving puzzles could spill over and help people solve puzzles that use a completely different set of rules. Imagine learning to solve a Sudoku puzzle and then trying to solve a crossword puzzle with that same knowledge. Does it help? Or is it like trying to learn a new language based only on your knowledge of cooking? They're everywhere, right? From math homework to planning your week. And with all the new tech out there, understanding how we learn to solve problems is becoming super important. It takes a lot of time and effort to learn lots of different things. So, if we could learn one skill and have it automatically help us with many others, that would be amazing for training super efficient. But the big question is, can it actually happen? So the scientists designed a study to find out. They created two different sets of puzzles. Let's call them puzzle set A and puzzle set B. These puzzles look the same on the screen, but the hidden rules you used to solve them were totally different. They took about 73 people and split them into two groups. One group spent 4 days practicing puzzles from set A. Every day, they do a bunch of these puzzles. Then, at the beginning and end of the whole experiment, they would also try some puzzles from set B, the ones they didn't practice. The other group did the opposite. They practiced set B puzzles and were tested on set A. So what did these puzzles look like? Imagine you have a string of symbols like ABC and a goal, say CBA. You are given a set of rules that let you change parts of the string. For example, a rule might say you can swap the first two symbols. You have to use these rules to get from the starting string to the goal string. They had to figure out the right sequence of rule applications. They could try things out, undo mistakes, and start over. The researchers tracked everything, how many puzzles they solved, how quickly they solved them, and even how long they took to decide which rule to use. Each puzzle set had 72 unique challenges. The key thing was that the rules for set A and set B were completely different. You couldn't get the rules for set B just by swapping out symbols in set A's rules. They were truly separate systems. After each set of puzzles, they also filled out surveys asking how they approached the problems. They described strategies like work it out, where you think before you act, try, and see, where you just pick a rule and see what happens, and intuition, where you just go with your gut feeling. Oh, and to check if memory played a role, they also did a memory task. It was like trying to remember a list of numbers that gets longer and longer. This is basically to measure how much information people can hold in their minds at any one time. So, what happened? Well, people got much better at solving the puzzles they practiced. Their success rate went up and they got faster. That is what you'd expect. The interesting part is what happened with the puzzles they didn't practice. They did see a small improvement on those too. But here is the kicker. The researchers found that these small improvements were about the same as what you'd expect just from doing those puzzles at the beginning and end of the study. During the probe blocks, it wasn't like they were learning something new from their practice that magically helped them with the other set. Similarly, they got more efficient with the puzzles they practiced, meaning they took the most direct route to the solution. But on the untrained puzzles, there were only small gains in efficiency. Again, not much more than just practicing those few puzzles directly. What about the strategies? People didn't really change how they said they approached the puzzles over time. But interestingly, the work it out strategy, where you think before you act, was always linked to making better choices, no matter which set of puzzles they were doing. So, the main finding is pretty clear. There wasn't much evidence of transfer. Practicing one type of puzzle didn't seem to make people significantly better at a different type of puzzle that use different underlying rules. This is where it gets really interesting for how we teach and learn. If learning can't easily jump between different rule sets, it means that to get good at lots of different problem-solving domains, you might need specific training for each domain. General training might not be as powerful as we hope. Why didn't learning jump across? The researchers propose a few ideas. One is that switching between rule sets might overload your working memory. You have to hold onto the new rules and maybe unlearn associations from the old rules. Another idea is that maybe people didn't actually reuse the same problem-solving strategies or heuristics when they switched tasks. Even though a state value heuristic could theoretically let you transfer knowledge, maybe people's brains just didn't do it. They might have developed task-specific state value heuristics for each puzzle set. Think of it like this. Imagine you have a master recipe for baking bread. That is your generalized knowledge. You can use it for sourdough, whole wheat, or focaccia. That is good transfer. But what if for some reason your brain decided there is a completely different bread baking engine for sourdough and another for whole wheat? Even if you were a master baker of sourdough, that knowledge wouldn't automatically help you with whole wheat because your brain built separate systems. Now, the study did do something cool. They built a computer model, a state value heuristic, and showed that it could actually transfer knowledge between the two puzzle sets. This shows that it is possible for this kind of transfer to happen, at least computationally. However, this doesn't mean humans actually do it in this situation. So, what is the takeaway for us? The big implication is that if you want to get better at many different kinds of problem solving, you might need targeted training for each. Broad general problem solving. Training might have its limits, especially if the underlying rules are different. It is like saying that learning to be a world-class chef might not make you a world-class surgeon. Even though both require complex skills and knowledge, in essence, this study suggests that when it comes to problem solving, learning doesn't always hop across to new domains as easily as we might hope, especially when the fundamental rules change. It seems our brains might prefer to build specialized pathways for different sets of rules rather than relying on a single universal problem-solving engine. Now, what is my take on all this? I think this study is super important because it challenges the idea that general problem-solving training is a magic bullet. It forces us to think more deeply about how learning transfers and how we can design training programs that are actually effective. The fact that they showed it is possible for a computer model to transfer learning is fascinating, and it makes us wonder why humans are different. Maybe it is efficiency. Maybe it is to avoid interference, or maybe our brains just aren't as good at abstracting general principles as we'd like to believe. A key limitation here is that while they didn't see transfer in humans, their model did. This leaves open the question, is it about the type of heuristic, the reasons humans might not reuse it, or something else entirely? Future research could explore how to nudge people to actually reuse those learned state value heuristics, perhaps by making the two task sets more similar in certain ways, or by actively encouraging metacognition, thinking about thinking. So, if you are looking to boost your problem-solving skills, remember that practice makes perfect, but for different types of problems. You might need to practice each type specifically. What do you guys think? Does this resonate with your own experiences learning new things? Let me know in the comments below. And if you enjoyed this breakdown, don't forget to like this video and subscribe to RUBIN'S Mind Lab for more explorations into the amazing world of psychology. We'll see you next time.